Hi, today we are going to discuss about surface properties. Surface properties is the study of the characteristic of a surface when in contact with another material, including molecules. The content includes surface tension, interfacial tension, and dispersed system, which includes emulsion and forming.
What is interfacial phenomena? Interfacial phenomena occur at the interface between two different phases. Interface is the boundary formed when two phases exist together. Thus, interfacial phenomena are associated with dispersed system. There are two types of interface, which is rigid interface, which is not flexible, and non-rigid interface, which is flexible. Interfacial tension is an inward attraction between the molecule, which is the force that exists between the molecule. For gaseous particles, we call it van der Waals interactions. It is an important parameter in emulsion stability.
Surface tension is the tension of the surface film of a liquid caused by the attraction of the particles in the surface layer. The attractive force exerted upon the surface molecules of a liquid by the molecules beneath that tends to draw the surface molecules into the bulk of the liquid. Thus, surface of a liquid tends to behave like a stretched elastic membrane. The examples of surface tension are walking on water, floating a needle, soaps and detergent, and surface tension disinfectants. Interfacial tension versus surface tension. Molecules at the interfaces have a higher energy level, which is also called as surface tension, than those in the interior of the material, which is interfacial tension. Molecules at surface form stronger bonds, therefore they are able to form a layer. Minimized available surface area will minimize energy required.
Interfacial tension and surface tension are both surface phenomena of liquid surface, and both are based on intermolecular forces, cohesive and adhesive forces between liquids. The tension between surface tension is between air and liquid. However, for interfacial tension, the tension is either between surface tension of two immiscible liquids or between two molecules.
Dispersed system is a kinetically stable system which consists of one or more discontinuous phases in a continuous phase. Each phase can exist in solid, liquid, and gaseous phase. This picture shows the dispersed phase and the continuous phase. The properties of dispersed system are very small to naked eyes
and will be affected by both gravitational force and thermal diffusion.
And lastly, large surface area. In a fixed composition, when the size of the particles decrease, the number of the particles will increase, thus increase the area of interfacial contact. We are going to discuss about emulsion and form.
Emulsion is a colloidal dispersion in which the liquid is dispersed as droplet in another liquid, and it is not soluble or miscible.
There are two types of emulsion: oil in water emulsion, which oil phase is dispersed in water. The examples are mayonnaise and milk. On the other hand, there is water in oil emulsion, which the water phase is dispersed in oil. For example, margarine and butter.
There are also multiple emulsions such as oil in water emulsion and water in oil in water emulsion.
The stability of the emulsion can be affected by a few factors. They are
viscosity of the continuous phase,
the presence of the surfactant,
size of the droplets,
and the ratio of the dispersed phase and the continuous phase. Forming is a colloidal dispersion in which gas is the dispersed phase and liquid is the continuous phase. It is a process of modification of liquid by reducing the density of the original liquid.
It contains a third phase such as oil or fat in form used in food system.
This process contributes to volume and also texture, as when the volume increases during the forming, the texture of the food will become softer. Hence, the density was reduced.
Lastly, it has a low surface tension to form foam.
Overrun refers to the amount of air pushed into the food while it is being made. This process involves whipping or aeration. Whipping causes air to be incorporated into the liquid. After whipping, volume of the formed liquid increases extensively compared to the original volume. The examples of food products that involve the process overrun are commonly ice cream and marshmallow. Fun fact, ice cream needs an overrun of less than 50% to be considered super premium. Do watch out!
Both emulsion and foam, as well as other types of dispersed system, are not stable as initially as its original state and will separate after some time or immediately in some cases, as they are not miscible or soluble in each other phases, therefore require surfactant to prevent separation.
There are a few types of emulsion instability. They are creaming, where less than phase rises causing the floating of oil droplets on surface emulsion.
Sedimenting, opposite of creaming, in which the precipitation of oil droplets at the bottom of emulsion.
Phase inversion, internal phase become external phase, but this is not common.
Flocculations, small oil droplets merge together to form a larger flux.
Coalescence, small oil droplets merge together forming a larger mass, and slowly a layer will be formed on the surface and eventually causing the separation of two layers.
Outward ripening, small oil droplets merged into a larger mass.
Foams are subject to three main types of instability. Outward ripening, the diffusion of gas from small to larger bubbles due to the pressure of small bubbles is greater than the larger ones.
Drainage of liquid from and through the foam layer due to gravity.
Coalescence of bubbles due to instability of the film between them.
Surfactants stabilize the emulsion and foam by lowering the interfacial surface tension between the dispersed particle and the continuous phase.
An emulsifier consists of hydrophilic part and hydrophobic part. The hydrophilic part will bind with the aqueous phase, and the hydrophobic part will then bind to the oil phase. Therefore, the emulsifier is positioned between the oil and water and thus reducing the surface tension between the oil and water. Emulsifier only provides short-term stabilization as it will reach critical micelle concentration. When critical micelle concentration reach, micelles start to form when emulsifier is continuously added. So, stabilizer is added to provide long-term emulsion stability.
Stabilizers that are generally proteins or polysaccharides are able to provide long-term emulsion stability by increasing the viscosity of the continuous phase so that it is more difficult for the dispersed molecule to move and coalesce with each other. Did you hear that? It's winter season again!
Again?
Imagine yourself having a cup of hot chocolate.
Or even when you gather around a campfire.
There's nothing better than the accompaniment with
Marshmallows! Did you know marshmallow is one of the popular confectionery over the centuries?
During ancient times, Egyptians made marshmallow by hand by extracting sap from mallow plants and mixing it with nuts and honey. The roots and leaf of the marshmallow plant contain mucilage, a slimy texture dimulant that's not for its use to cure sore throat. Marshmallow root is considered to be soothing and antimicrobial.
Wow, marshmallow is used medicinally to cure sore throats and not as confectionery at all during ancient times. The important ingredients in making marshmallows are egg white, gelatin, corn syrup, and sugar.
So, what is the science behind marshmallow? Gelatin is added into the making of marshmallow to act as emulsifier as well as stabilizer. But what is gelatin and how does it work?
Gelatin is a protein that comes from collagen, the main protein in connective tissue in animals. It has the ability to coagulate when it is beaten or whipped. When the hot concentrated syrup is beaten into gelatin with the mixer, bubbles form in the mixture and the gelatin coagulates around the bubbles, stabilizing their walls to prevent collapsion.
Foams combine two immiscible substances, air or gas is entrapped within a fluid or solid. Whiskey incorporates air into the cream, and the newly introduced bubbles are held captive by the structures of the foam. Fluid and gases have very different properties, so how does agitation keep them together?
Agitation disorients the fat globules and strips away their protective membranes, forcing them to cling to other fat molecules or aggregate around air bubbles. Physical force applied like mixing will break the surface tension, and air is able to incorporate in. Anything involved must be avoided having to be in contact with water.
There are some factors that will affect the quality of marshmallow by affecting the stability of dispersed system. The first one is aeration, and the second is emulsifier.
Fluffy texture.
In order to provide more fluffy texture to the marshmallow, more air is needed to incorporate into the mixture. Aeration properties of foam were measured in terms of forming capacity and foam stability. Forming capacity was expressed in terms of percentage of overrun. Thus, this can be monitored by overrun. Air in solid or liquid? How?
Gelatin is added in the making of marshmallow to act as emulsifier as well as stabilizer. Gelatin is an efficient foam stabilizer by preventing the coalescence of bubbles. Thus, the amount of gelatin added should be enough to make sure the mixture and air bubble is well distributed. Surface properties is indeed a critically important aspect in a number of industrial applications such as packaging, polymers in coating operation, pharmacy and biomedicine, printing, cleaning, the making of textile like hydrophobizations of waterproof clothes, lubricants, spreading of inks to determine the printing quality of the ink, electronics, and adhesive on various substrates. Specifically, there are also some importance of emulsion in food industry. To increase product stability and obtain a tolerable shelf life level,
To change crystallization of fat,
to modify functional properties of food components,
to regulate food product viscosity such as fillings.
able to improve volume in some food products such as cakes, marshmallow, and ice cream,
increase fat dispersion in ice cream,
provide a higher resistance to mixing and mechanical exploitation of dough conditioner,
and prevent separation of oil and water like peanut butter.
Thank you for watching our video. Bye!